For question 1b, we're supposed to calculate the phasor currents in the circuit and plot them in the diagram. So first, let's calculate what the phasor currents are. So we're going to see that there's a relationship between the total phasor current I and the branch currents IR, IL, and IC. So we know that, let's say, the total current I is equal to IR plus IL plus IC. Now, we can use Ohm's law to calculate the individual phasor currents in the branches. So then how that's going to look like is going to be the phasor voltage is equal to the phasor current times the impedance. So this is the complex form of Ohm's law. So then we can start calculating for the individual branch currents. So let's do IR. So IR is going to be equal to the phasor voltage divided by the resistance. So the impedance for the resistor is the resistance, and we're given the phasor voltage as 4 at a phase angle of 90 degrees, and the resistance is given as 4 ohms. So that's just 4. And then when we compute, we just divide the magnitudes so that it's 1. 4 divided by 4 is 1. And then the phase angle is 90 degrees. Okay, so that is a magnitude of 1 at a phase angle of 90 degrees. And that's 90 degrees from the positive real axis. So let's just draw this one. So this one is IR. And then the 90 degrees is 90 degrees from the positive real axis. Okay, so that's what that means. And this magnitude is 1, so it's got a magnitude of 1. Okay, and it's obvious that it's at an angle of 90 degrees because it's right on the imaginary axis. Okay, let us calculate the inductor current. Okay, so I'm just changing colors. And that's going to be IL. It's going to follow the same form, voltage divided by the impedance, and in this case the impedance is J4. Okay, so what's that equal to? For the voltage, it's the same as it ever was. It's 4 at a phase angle of 90 degrees. And what is J4? Okay, so in case that's confusing, J4 is a point on the it's on the positive imaginary axis, right? So that's 4, and there's no real component to it. Okay, and so that's going to be a magnitude of 4 at a phase angle of 90 degrees. And then when we're doing computations with polar coordinates, with phasors or complex in complex form, we divide the magnitude. So 4 divided by 4 is 1, and then we subtract the phase angle. So the one on top stays, so that's 90 degrees, and it's minus the phase angle on the bottom, so it's minus 90 degrees, and that becomes equal to 1 at a phase angle of 0 degrees, and it's just 1. Okay, so that's a real number. It lies on the real axis, so I'm just going to draw that phasor current. It's going to be out here like this. So that's IL, and it has a magnitude of 1. Okay, so let us do IC. So IC follows the same form, voltage divided by the impedance, and it's given to us, for the capacitor, it's given to us as minus J2, so we put minus J2 here. Okay, so the voltage is 4 phase angle 90 degrees. So J2, let's just sort of refer back to this. J2 is minus 2. There's no real component, so it's at a minus 90 degree phase angle. Magnitude 2 minus 90 degrees. Okay? So then we divide the magnitude, so it's 4 divided by 2, which is 2. And then we subtract the phase angle, so the one on top is 90 degrees minus the one on the bottom, and that's given to us as minus 90 degrees. Okay, so that is equal to 2 phase angle 180 degrees. Okay, so that's like way out here, right? And so that's 180 degrees. It's the same as saying minus 2 at 0 degrees, and we can just say minus 2 because it's purely a real number. So we can plot that out. So that's going to go out here as a magnitude of 2. Okay. Sorry, magnitude of minus 2. Okay, let's tidy that up a little bit. Okay, so then, oh, sorry, and that was IC. That was IC. So now let's do the total current. I'll use a different color. So I, that's the total current. We said that's equal to IR plus IL plus IC. Okay, let's put in the values for those currents. So IR, that had a value, let's say, let's go back and do the rectangular form. So this becomes J1 in rectangular form. This is already in rectangular form, this is already in rectangular form, so we can just continue. Okay, so IR has got a value of J1. IL has a value of 1, and IC has a value of minus 2. Okay, so then when we simplify it and put it into standard form, we have minus 1 plus J1. So what does that look like? So we have the imaginary, we have the real, so it's minus 1 and then plus 1. Okay, so then we have a point here. So then well, we know that this is an angle of 45 degrees here, right? And so this one must be 135 degrees. And then what's the magnitude? The magnitude is going to be 1 squared plus 1 squared, which is obvious, and it's square root of 2. So that's got a magnitude of square root of 2. So let's plot that up here. So it's going to be going out here and out here, and it's going to be up here, and that's going to be I, the total current, and we're going to have a phase angle of 135 degrees and a magnitude of root 2. Okay, so that's how we solve for these phasor currents.